This is Darrell presenting Apple's Develop in Swift Fundamentals curriculum, Unit 3, Lesson 3, Guard. You might recall earlier we discussed how nested if statements can become difficult to parse. That's called the pyramid of doom. Swift includes a guard as another way to make code more readable. Here's an example of code that is hard to read. The function is sing happy birthday, and if the birthday is today, and if the invited guests list is not empty, and if the cake and candles are lit, then you can sing happy birthday. But if the cake is not lit, then you say the cake hasn't been lit, and if the invited guests are not empty, you have an else statement down here where it's just a family party, and if birthday is not today, you've got your else statement down here. The else clauses are far away from the corresponding if clauses. And the important code, which is the code you execute when all of your conditions are successful, is indented very far in. This is difficult to read. What we want is another way to do a conditional which eliminates this pyramid of doom. Here's one way to solve the problem. In this case, we've inverted our if statements. So we do if not birthday is today, then no one has a birthday today, and we return early from our function. If the invited guest is empty, then we print out our error message and return early from the function. If the cake and candles are not lit, then we handle the error and return early from the function. And then we get down to our actual code that we execute when all of our preconditions are met. In this case, the error code associated with failing to meet each condition is close to that condition, which is an improvement, and our important code, which handles all the preconditions, is in the place we expect after all the preconditions, but Swift still has a better way for us to do this using. Here is the guard statement, which is exactly like an inverted if statement. We guard that the condition we want is true, else we perform our error handling, and guard requires us to include a return or at least a move of control out of this guard position. Then we check our next precondition, and if the next precondition is not true, then we have our error handling code also requiring a return. We check our final precondition, and then we handle the error message if the precondition is not true. And then we are down at our good code, which is not indented. This is our all conditions okay code, which can do our work based on the fact that our preconditions have been met. A guard is like an if-else statement. The else clause is executed if the condition is false. Otherwise, you continue on and execute the true code. Here are two possible implementations of the divide function. In both of these implementations, we are checking that the divisor is not equal to 0. In the first implementation, we are using the if statement to check that the divisor is not equal to 0. And then this is our happy condition where we calculate the result and print the result. Here's the alternative where we're using the guard. In the guard, we check that our preconditions are met, and if our preconditions are not met, we return early. And then down here at the bottom is our happy code where all of our preconditions are met, and then we do our work. Here's another example of the good path being indented. Here we're conditionally unwrapping an optional, and if we successfully unwrap the optional, then we execute our print statement using our non-optional eggs. But with the guard, we test that we can unwrap our goose eggs and have a non-optional eggs. If we fail to unwrap them, then we have an error condition and we return out of our function. But if we successfully unwrap them, then eggs is accessible for the rest of our function, which is really cool. This way, you could have guard statements to. Here's another example where we have a function where it receives 3 parameters, all of which are optionals, and in order to do our work, we need to unwrap all of them. With the if statement, with if let, we could unwrap all three optionals on one line, and then our happy code is indented. Alternatively, with the guard statement, we could unwrap all three of our optionals. If we fail to unwrap any of them, then we execute the else code and deal with our error and return early. And then for the rest of our function, we have three non-optionals that we can work with on our happy path and do our work. If you are using the Apple curriculum, now you can open up the Guard playground and complete the exercises in the lab. The slide deck is copyright 2021 by Apple. The slide deck is licensed by Apple under the Creative Commons Attribution Non-Commercial Share-alike 4.0 International License.